My name's Elena McHale, and I'll be presenting the past and predicted future of software reuse as a potentially dying discipline. The research question of this paper is software reuse a dying discipline based on the past, present, and future of this field? And then off of that, what are some potential future research topics in regard to software reuse? The motivation of this paper stems from a 1994 prediction that software reuse research would eventually cease to exist, and this makes it necessary to evaluate software reuse to find if that prediction is soon to become a reality. Reuse is the process of creating new software from the existing software. There are two types of reusable assets: vertical, which is an application domain-specific asset, and horizontal, which is independent from application domains. So in 1994, Ruben Puerto Diaz made a prediction that the death of software reuse research was on the horizon. He highlights his predictions with 7 ideas of the future, and these include: reuse will become integrated into software engineering, organizations will establish reuse programs, software development environments will support reuse tools and domain engineering, there will be an emergence of reusable parts industry for specialized domains, development standards will adapt to support reuse, domain engineering will be a dominant discipline, and software reuse will cease to exist. Fascinatingly, while tracing back software reuse history, we can actually identify that the first 6 predictions can be seen. However, the last one is still not a reality, which is what the motivation of this paper leads us to. So the forms of software reuse are domain analysis, generators and transformational models, components, languages, and code reuse, and then reuse code models. Domain analysis is a technique to identify the relevant objects and operations in a domain. Many reuse approaches focus on code and architecture instead of domain, so this isn't very relevant today. Generators are used to produce executable code based on reusable code. Transformation turns abstract ideas into concrete programs, which could speed up the task for programmers. This is also not largely used because we have replaced them with libraries and components. So on to the next, components, languages, and code reuse. So this form is the most primitive way of reuse because it avoids writing duplicate code altogether. And then reuse code models deal with the economic time principle of time to payback, and it identifies the strategic support that reuse could give a company and its market strategies. So now getting into models and metrics of software reuse. Reuse cost-benefit models are used for economic cost-benefit analysis. There are 3 types of models that I'll discuss. The simple model that shows the cost of using different software components. The cost development model, which is like the simple model, but it also represents the cost of developing reusable components. And then the quality of investment metric, which is a ratio of reuse benefits compared to the reuse investments. Maturity assessments are beneficial when categorizing reuse programs and how advanced they are in implementing systematic reuse. The columns and phases are, the columns are the phases, and then the rows represent dimensions. And then in each dimension, an organizational involvement and commitment will increase from the initial reuse phase to the ingrained reuse phase. And that is represented on the bottom here in this diagram I made. The SPC reuse capability model, this has 2 components: the assessment model and the implementation model. So the assessment model is a set of critical success factors that an organization may rely on to gain insight into the present state of reuse. The implementation model will prioritize goals and provide stages of implementation. Moving on to the amount of reuse. This is used to assess reuse improvements by tracking percentages of reuse for lifecycle objects. So in the reuse level metrics, this is a measurement based off of the idea that systems have different levels of abstraction. An internal lower level is developed for higher level components, and the external lower level is used by the higher level, but it's generally created for a more general use. And then the higher levels are actually just defined by the lower level items that make up that higher level. So the reuse metric for object-oriented system calculates the difference between views of reuse and is split into 3 profiles. So the server reuse profile characterizes how the class is used by the client class. The client reuse profile characterizes how a new class reuses an existing library class. The system reuse profile characterizes the percentage of source code imported from the library. So then moving on to reuse predictions for lifecycle object models. And this is unique because typically we think of code when we think of reuse, but this model actually lets you predict the reuse levels for a lifecycle based off of reuse levels for another past lifecycle. So then the software reuse failures is a type of model that identifies and orders errors that can be associated with reuse. The organization will gather data on the failure modes and causes of those different modes, and then use that information to improve its reuse activities. Reusability assessments are used for indicating the likeliness that a component is reusable. And then finally, the reuse library metrics are used to create classification schemes that are enumerated, faceted, and free text indexing. So some barriers of reuse actually occur through the entire software lifecycle. In the early stages of asset creation, there is a low availability of domain knowledge, a lack of reuse policies in creating assets, a lack of funding, a lack of training and mentoring, and reuse technology isn't very defined or supportive. The asset utilization stage, you can see a difficulty in accessing the assets in unorganized software libraries and a lack of support while integrating assets. And then finally, in the asset management phase, there is evidence of failure to periodically update assets or improve their quality at all. Going on to the people, I guess I could say, in the organization that typically create barriers. So the first would be top management. And management can be imposed to software reuse just due to the lack of qualitative measures that assess benefit and cost. And then software developers can also create barriers because they believe that reuse inhibits creativity and is developer dependent when it comes to locating correct domains. But asset developers can actually realize the struggles that come from heavy documentation that is necessary when you're going to be reusing a system from the past. And then it should be mentioned that organizations only really see value if they're willing to modify their business practices to accommodate for reuse. The barriers that were just highlighted may leave you under the impression that the prediction that was highlighted may be in view, but there are trends in the software engineering world that could allow reuse research to prosper. So the first trend is knowledge reuse, and this stems from the rise in big data and artificial intelligence. This would allow reuse in artifacts and abstraction as opposed to the way developers have used reuse in the past. Trend 2 is reusable system features, and this comes from a rise in cyber software engineering. This gives the possibility of suggestion engines and feature locations that could make an impact on how the developer finds reusable assets. Trend 3 is reusable services, which comes from the increasing interest in service-based trends. Re-engineering conventional systems, transitioning to service-based software with different granularity levels is completely possible in the future. And then the last trend is reusable machine learning components, which obviously stems from the interest in machine learning, and this could possibly lead to machine learned knowledge being the primary content of reusable components. In conclusion, a brief history of software reuse, the forms, models and metrics, barriers, and predictions are described in this paper. Evidence shows that there is still a lot to be discovered and researched in software reuse. There is a possibility of death of software reuse, but it's not in the near future. A couple of ideas for future work would be case studies into businesses who have successfully adopted software reuse, as well as open-ended interviews with experts in the field to gain insight into what their opinion is about if reuse will actually remain prevalent. This paper allowed me to explore questions about software reuse that I haven't had experience with before. Although the predictions come from the past and present evidence, there may still be a new development that completely erases the need for software reuse, and it's not something we can foresee right now. And here's my references.